Hello, this is an Algebra 2 video, Chapter 4, Section 5. We are learning today how to complete the square. We have in this chapter been learning how to solve quadratic equations by graphing. We've done factoring, and now we want to solve quadratics by completing the square. But before we get going, I kind of want to show you first and foremost what it means to complete the square. At least in a practical sense. So, normally you would try to move the 36 to the other side and make it equal 0. But lo and behold, in this section you want to caution yourself. Sorry about that. You want to caution yourself and not assume to go there right away. And I'll tell you how you know that's the case. Whenever you see this c value, because again you want to remember that it's ax squared plus bx plus c. Whenever this c value is a perfect square, that's kind of a huge indication to you that you might want to double check that you can do it a different way instead of automatically subtracting the 36 to the other side. So I'm going to note that in do-it-yourself number 1, there's a 36, which is a perfect square, 6 squared. 64 is a perfect square, it's 8 squared. So I want to caution you with that. So then instead of moving the 36, if I'm not going to move the 36, then what I do is I'm kind of just going to concentrate on this portion and leave the 36 over there for the moment and try to factor the left-hand side the way I normally do. So I'm going to put a 1 and a 1, and because that's a perfect square, it's supposed to be 3 and 3. In other words, these numbers should be the same because 3 times 3 is 9, and then 3 plus 3 is going to be 6, which is our middle term. So it turns out that when I factor this, I get x plus 3 times x plus 3. In other words, x plus 3 squared equal to 36. And when you have, and that's basically, by the way, what we mean by completing the square. This is actually already, we're not completing anything. Completing implies that you have to complete it, you have to finish it. But in this case, it's already finished. This is already a perfect square. And this is what a perfect square looks like. When you get the same factor twice, just like 4 is a perfect square because 2 times 2 are factors. 9 is a perfect square because 3 times 3 are factors. X squared plus 6x plus 9 is a perfect square because x plus 3 and x plus 3 are factors. So you write it like this, and then when it says solve by using the square root property, what it means is that because it's already squared, all you have to do to solve this problem is to square root both sides. And then you're going to get the square and the square root will cancel, and so you'll have x plus 3 equals, don't forget the plus or minus, and the square root of 36 is 6. And then you want to subtract 3 from both sides to continue to solve for x. And when we put plus or minus, it means that there's 2 possible answers. It's either going to be positive 6 minus 3, which is 3, or negative 6 minus 3, which is negative 9. And you get 2 solutions. Okay? So that is how you do example 1, and I would like you to try the same thing with do-it-yourself number 1, A and B. Then we will go to example 2, and in example 2 we're going to do the exact same things, exact same directions, but this time what you see over here, the 27, is not a perfect square like it was earlier. We had a 36. You can see here that we got 25 and 49, and those are all perfect squares, so your answers are going to all be nice and easy to, they're going to be rational numbers basically. But here you're going to get irrational, and I'm going to show you how that works. But again, I look at the 25, and the 25 is a perfect square. So instead of moving the 27 over, I'm just going to leave the 27 over there, and I'm going to try to factor the left. So I get 1 and 1, and again 5 and 5 is 25, and 5 plus 5 is positive 10. So I'm going to make these both negative. So I can get negative 5 times negative 5 is positive 25, and then negative 5 plus negative 5 is now negative 10. So I got to make sure that my numbers work right. But I get the same factor twice, so that means I'm going to get x minus 5 quantity squared equal to 27. So that much is the same as before. I square root both sides. It still cancels, but this time I get plus or minus 27, and 27 is not a perfect square. So we have to break that down into 9 and 3. And the square root of 9 is 3. So we get plus or minus 3 root 3. And 3 root 3 is irrational. So if you remember, a rational number is a number that can be written as a fraction. It has a decimal that ends like 0.25, 0.7, 0.6, 0.625. These numbers are going to have decimals that never end, okay, and they have no pattern, and so they're considered irrational. But we're still going to add 5 to both sides, and this time our answer is going to look a little different. But basically it's going to be 5 plus or minus 3 root 3, and you are welcome to leave your answer like this. Some people, in order for you to see that there's actually 2 answers, you can also write x equals 5 plus 3 root 3 and 5 minus 3 root 3, or you could combine the plus or minus here and write it like that. Either way is fine. But they are 2 different answers, and no, we don't want decimals, just leave the answer like that. So now you want to do that method or that process for do-it-yourself number 2. And then we're going to get to example 3, and so far we still have not, I mean, we kind of know what a perfect square is supposed to look like, but we still haven't actually done the process of completing the square. This is the last thing we're going to do before we get to that. But it says here, find the value of c that makes x squared plus 16x plus c a perfect square. Then write the trinomial as a perfect square. So you probably noticed that the number here is always a perfect square, okay? But what about this number? So I'm going to show you how this works. And basically that c value is going to equal b divided by 2 squared, okay? Now that's all based on the ax squared plus bx plus c thing, okay? Yeah. So, and that should be 2a, sorry. B divided by 2a squared. Okay, it's a formula. So right now you're probably not understanding why the formula is that way, but that is the formula. You take b divided by 2a. So in this case, my a value is 1 and my b value is 16. So in order for me to find out what c is supposed to be, I have to take b, which is 16, divided by 2 times 1, and then square it. So that's going to equal 16 divided by 2, which is now 8, and then I'm going to square that, and that's 64. So in this case, c has to equal 64. So that's what c has to be. It told us to find the c value, and then they want us to write the trinomial as a perfect square. So now I have to actually write it all out. So that's going to be x squared plus 16x plus 64. And then to write it as a perfect square, we're actually going to take and factor it, and you're going to get 8 and 8, and 8 plus 8 is 16, which is the middle term there. So to write it as a perfect square, you're going to go x plus 8 quantity squared, and this would be your final answer, that and the 64, because they didn't want you to find the value of c that would make this a perfect square. So now we want you to do that for do-it-yourself number 3, and then we will move on to the actual process of completing the square. We're almost there, folks. Okay, so example 4 says solve x squared plus 10x minus 11 by completing the square. And this is where I'm now going to actually show you the steps, okay? And it's kind of weird. So step number 1 is to divide by a. Now in our case, our a is a 1, so when we divide by 1, we're going to get the exact same thing. But in the next example, you're going to see that there is going to be an a value that's other than 1, and I want you to know that that's the first thing you want to do is divide by a. The second thing you want to do is subtract c to the other side. Okay, in other words, you have ax squared plus bx plus c, the negative 11. So we want to basically go x squared plus 10x and then blank equals 11. I'm going to move this guy to the other side, okay? And these actually 2 steps can be done in either order, but there we go. So we move the negative 11 to the other side. Step 3 is divide b by 2. Okay, so in this case, my b is 10 divided by 2, which is now 5. Okay, so in step 4, you want to square the result. So the result was 5, so now I'm going to square that, and that's going to give me 25. So in step 5, we're going to add result of part C, or sorry, of step 4, add result to both sides. Okay? So now I'm going to put a plus 25 here and a plus 25 there. I'm going to add it to both sides. Okay? So this now, hopefully, it will make sense why we call it completing the square. Currently, if I were to factor this right now, negative 11 is not a perfect square, so it's not going to end up being 2 perfect factors like it has been in the previous examples. So what we want to do is get rid of that number because it's not the right number, and then we want to put the right number here, and you can see now that 25 is a perfect square. So now this is going to work out nicely so that when I factor, I'm going to get a perfect square. So at this point, we can actually continue to do the problem in much the same way that we did in the previous examples. So for step 6, you want to factor the expression or rewrite. Actually, I'm just going to put rewrite because I want to show you right now. Oops. So we're going to put factor / rewrite as perfect square. Okay, so what that means is, at this point, I want to factor this guy, 1 and 1, 5 and 5, and this time 5 plus 5 is 10, and 5 times 5 is positive 25. So I have the same factor twice, so I'm going to get x plus 5 times x plus 5, or x plus 5 squared. On the right, I get 25 plus 11, and 25 plus 11 is actually 36. And now I can actually, but before I solve this, I want to show you something that's really unique about these problems, and it's always going to work. So when I put their factor, you don't have to do this every single time. The completing the square process is guaranteed to give you a perfect square. So instead of having to figure this out all the time, you should notice that the number that ended up being inside of the perfect square here is a positive 5. And it's no coincidence that that same number is this number after you divide it by 2. So whatever this number is, that will always be this part in here. So you can actually skip the factoring phase and go straight from here to here. Now as far as solving it, we did that already before the previous examples. You square root both sides. X plus 5 equals plus or minus 6. Subtract 5 from both sides. Positive 6 minus 5 is 1. Negative 6 minus 5 is negative 11, and you get your 2 solutions. Okay? So I would like for you to complete the square in your attempt to do yourself number 4. And have no fear, we're going to do more completing the square examples, as number 5 is another one, and I think 6 is the last one. So we have 5 and 6 to go. All right, so in example 5, and example do it yourself 5 also, you'll notice that all of these examples have a B, or sorry, an A, that's not a 1. So this is going to get a little bit more complex than the one that we just did, but it's not a big deal. So like I said, you can interchange the first step. So if you want to subtract the 5 from the get-go, you can. It's not going to affect your final answer. I always like to put a blank there because it reminds me that I'm going to complete the square, that it's missing something, and I'm going to put it in there. The second step, if you remember, was to either divide by 2 or to move the C to the other side. But I did not order this, just to show you it doesn't matter which way you do those first 2 steps. And so when I divide, it doesn't matter if 2 doesn't go in evenly. You still have to put minus 7 halves x blank equals negative 5 halves. Okay? Now I'm going to take my b, and b is the number right here in front of x, and I'm going to take negative 7 halves, and I'm going to divide it by 2. Well, that's the same thing as negative 7 halves times the reciprocal of 2, which is 1 half. So I'm just showing you how to deal with fractions when you get them. Okay, so now this becomes negative 7 over 4, because negative 7 times 1 is negative 7, 2 times 2 is 4. So after all of that, it's kind of more complicated when you have a fraction divided by a number. But at the end of the day, dividing by 2 results in negative 7 to the 4th. Remember that earlier I told you that that number is very important. After you divide by 2, this is going to be the number that's inside of the perfect square factored form. But for now I have to square it, square my result, and then I'm going to put that squared result in my blank. So I'm going to go to my calculator, but I already know that negative 7 times negative 7 is positive 49, and 4 times 4 is 16. So I get 49/16 as my result after squaring. So that's going to go here, but whatever I add to one side, I have to add to the other. Okay? And this time I'm not going to factor it. First of all, it's going to be really ugly to factor with fractions. And secondly, I kind of already told you that there's a trick to that. So it's going to be an x, and remember, whatever the number was after you divided by 2, before you squared it, this number right here is what's going to go inside the perfect square. Okay? So you can factor this if you want, but it is true. Actually, I'll just do it because I don't think you believe me yet, but we can put negative 7/4, negative 7/4, and 1, 1. And if I take negative 7/4 and add negative 7/4, I get negative 14/4, and negative 14 over 4 is negative 7 halves, which was the middle term in the first place, and negative 7/4 times negative 7/4 is positive 49/16, which is C value. So it does work if you factor it, but it's just not necessary. If you follow the process of completing the square, you're guaranteed to get what we got here. Now what we want to do is take what's on the right hand side, so the negative 5 halves plus 49/16, and figure out what that is. So I'm going to use my calculator, negative 5 divided by 2 in parentheses, and add 49/16. My calculator loves to do fractions for me, so I get 9/16. And now I solve by square rooting. When you have a fraction, you want to square the top and the bottom. So that cancels, and I get x minus 7/4. Square root of 9 is 3, square root of 16 is 4. So I get plus or minus 3/4. I'm going to add 7/4 to both sides. So x equals positive 3/4 plus 7/4 is 10/4. And 10 over 4 is 5 halves. And then we're going to do negative 4 plus 7. Sorry, negative 3/4 plus 7/4 is going to be 4/4, which is 1. So negative 3, plus 7 is 4 over 4, so you're going to get 1. So those are your two answers, 5 halves and 1. Alrighty, so that is how you deal with there being a number in front of the x squared. You have to divide by that a value. Okay, so now we're going to do this one more time. So if you still feel like you haven't gotten used to it yet, we're going to do it one more time, and this time when we do it, we're going to end up with imaginary solutions. So lucky for us, in the previous lesson we already learned how to deal with that. So here we go. This one doesn't have a number in front of the x squared, so I'm going to skip that step of dividing, but we do have this c value that needs to go to the other side, so we're going to get x squared plus 8x, my blank, and then the 22 is going to go to the other side as a negative. And now I take my middle term, which is 8, divided by 2, which is then 4. I square that number, and I want to kind of highlight that because that number is going to matter later on. That's the number that's going to go inside of my factored form. Okay, but for now, 4 squared is now 16. So what's going to go in the blank here is the positive 16 on the left and a positive 16 on the right. So now I can write this in the factor form, and again I'm going to skip the factoring part and just use my trick of the 4, and it's going to be x plus 4 quantity squared, and this time 16 minus 22 is going to be a negative because the 22 is bigger. So you get negative 6, and so when I square root, I'm going to have x plus 4 plus or minus, but the square root of negative 6 is going to have an I in it, and 6 doesn't break down any further, so it's just going to be plus or minus root 6i. I'm going to subtract 4 from both sides, so my final answer will be x equals negative 4 plus or minus root 6i. And again, it's totally appropriate for you to leave your answer like that, or if you'd like, you can write them out separately, negative 4 plus root 6i and negative 4 minus root 6i, 2 separate answers, or you can write them as one. Okay, so now you will have to do it yourself number 6, and once you have completed that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.